I mean, 4.3 I'm named it this, but it's not like we've not been doing right triangle trig this whole time. But we're doing a little bit more today. Can I have you get your unit circle out, your page that you've written your unit circle on? Okay. Well, you're fired. No, it's okay. What we're going to do is we're going to slowly develop a ton of trig identities, and we're going to write them on the back of that so that you have this one place where you have the unit circle on the front and then your identities on the back. So what identities should we go ahead and write on the back? You can just write this on a piece of paper and put it all together. Or just in your notes, and then you can just say, like, I'm going to put this on there. So what all identities can we say that we know so far?
Cosine squared plus sine squared.
Okay, so we can write down the Pythagorean. Do you think we need to write down the reciprocal, or do you think you have those? Okay. All right. So the Pythagorean, go ahead and label them. And let's see if we can do them by memory. The first one was what? Equals 1. Okay, so sine squared plus cosine squared equals 1. Don't forget your variable. What? Oh, cosine squared plus sine squared. Yeah, I just always say sine squared plus cosine squared. Okay. Yeah, and that is one way to remember, like on your unit circle. Everyone writes sine squared plus cosine squared, so that's just like it's just a thing everyone does. But on your unit circle, that coordinate point, cosine and sine, C comes for S in the alphabet, so that's a silly way to remember it. But anyway, how do you figure out the other two? Okay, I'm going to divide by cosine squared. What's sine squared? What's sine divided by cosine? Tangent. So we've got tangent squared. What's cosine squared divided by itself?
1.
And 1 divided by cosine squared will the reciprocal of cosine, which is secant. So secant squared. And if we take the original and now we divide it by what? Sine squared. What's sine squared divided by itself? What's cosine divided by sine? So that would be cotangent squared, yeah? And then what's 1 divided by cosine squared? Cosecant squared. It's reciprocal. Okay. I think that's all we've learned on identities other than the reciprocal, right? And tangent and cotangent. Okay, we'll come back to this and add when we learn some more today. Let's get our unit, flip it back over to the unit circle. And let's find these values. Okay, let's simplify this expression. Did you take this with me yesterday? I can just give that one to you if I can find it right quick. So you got cosecant of negative pi over 6. There you go. Just give it back to me. Okay. So where is negative pi over 6? Okay. So negative pi over 6 is right here. Well, 30 degrees away. So like right there. What is that coordinate point? Square root of 3 over 2, comma, negative 1/2? Okay, so what is, well, okay, cosecants are reciprocal of what? So which one of those is sine? The negative 1/2? Did y'all write all that down already? Okay. Go ahead and write it down. Yeah, it's an expression. It's the first cosecant times the cosine minus the tangent. Okay, so we figure that the cosecant is the reciprocal of sine, and sine is the y-coordinate, and so what is cosecant of negative pi over 6? Negative 2. So negative 2 times. Okay. Cosine of 17 pi over 6. And why do you say 5 pi over 6? Good. So if you take 17 pi over 6 and you subtract 2 pi, and 2 pi is how many sixths? 12? So you do get 5 pi over 6. And that is right here. Okay, so if this coordinate point is what? What's it at 180 or pi? That's what it was at pi, but that's okay. Negative 1, 0, right? So 0, 1, and square root of 3 over 2, but you're in the second quadrant, so negative. All right, I need cosine, so which one is that? Good, negative square root of 3 over 2. Minus, now I need tangent of 5 pi over 3. So 5 pi over 3, right here, yeah? So if that one is square root of 3 over 2, square root of 3 over 2 and then negative 1/2, then this is negative 1/2 positive square root of 3 over 2. Cool? How do you find tangent? Sine over cosine. Now, so that means negative square or positive square root of 3 over 2 over negative 1/2. Do I have to work it all the way out like that though? Or do we know a shortcut? Right, so I can work it out, and I can multiply by the reciprocal, I can cancel out the 2's, or I can just remember I can divide the what by the what? The numerator by the numerator. Yeah? Okay, so what do I get? Okay, so negative square root of 3? Yeah? All right, what does that simplify down to?
Is it just gonna be 3 divided by 2? What's that? Oh, you're adding.
Mm-hmm. There you go. Yeah, the first one becomes just positive square root of 3 and then plus square root of 3. So then you get 2 square roots of 3. And there you go. Okay? Hmm? Hmm? There you go. Okay. All right. Let's do this one now. So sine of negative 4/3 pi plus cosine of 11/3 pi times sine of 7 pi. So sine of negative 4/3 pi plus cosine 11 pi over 3 times sine of 7 pi, all divided by tangent of 7 pi over 6 minus cosecant of 5 pi over 6 times sine of negative pi over 3. Okay, what is sine of, where is negative 4/3 pi? In quadrant 3? What is it? Where is 4/3 pi? Yeah? So if 4 pi over 3 is right here, then going forwards that much means going backwards. Well, okay. Thanks. Puts me right here at 2 pi over 3. Cool? Okay. So we're at 2 pi over 3. That is 0, 1, so that's negative 1/2 square root of 3 over 2. So what's sine of that? Okay, so square root of 3 over 2. Plus. Okay. Now let's do cosine of 11/3 pi. Where is 11/3 pi? And you got that from? Okay, 11 pi over 3 minus 2 pi. 2 pi is how many thirds? Oh, dadgummit. Someone, oh, yeah, there you go. Okay, so that would be 5 pi over 3. I agree. Where's 5/3 pi? Okay, so down here. So that coordinate point is 0, negative 1, so 1/2 negative square root of 3 over 2? Yeah? Okay. What am I needing? Cosine? What is the cosine? 1/2. Okay. Times, I need sine of 7 pi. Sine of 7 pi. Pi? Yeah, it's an odd pi, so it's over here. Sine is the x or the y? So what is it? Well, that's kind of nice because that just gets rid of all that crap, right? Okay, you're welcome. Oh my gosh. Because getting 0 is a waste of your time. But I wanted to put a second. Oh my gosh. 7 pi over 6, where's that? What quadrant? Okay, so in the 210? Yeah? Okay, so that's 0, so that's 1/2, that's square root of 3 over 2. Those are both negative. So tangent is what over what? Sine over cosine, which makes that what? Negative or positive? Good. And you said square root of 3 over 3? I agree. Okay, minus. I need cosecant of 5 pi over 6. 5 pi over 6 at 150? So if that's 0, that's 1. So that's 1/2 and negative square root of 3 over 2. And what is cosecant the reciprocal of? So what is sine? So cosecant is 2. Okay. Times, and then I need one more. I need sine of negative pi over 3. Where's negative pi over 3? Yeah, so same place that we had the 5/3 pi. Sine is the y value? So that is what? Negative square root of 3 over 2. Okay, so now we need to simplify this expression. Okay. In the numerator, we're just left with what? I'm going to go with square root of 3 over 2. And what happens on the right side of the denominator?
It tends to dominate. I'm just gonna stop talking.
What happens to the 2's?
Cancel out.
And then a negative times a negative? So I've got square root of 3 over 3 plus the square root of 3. What do you think I want you to do? Never leave fractions within fractions, okay? I want you to be able to simplify. Now, the only way that you can do the whole multiply by the reciprocal is if you have a single fraction of the denominator. Right now, you do not. So what do? Okay, so how? Okay, so find a common denominator, multiply top and bottom by 3. Good. So what does the numerator become of my denominator? We're adding, right? Exactly. So I've got square root of 3 over 2 over 4 square roots of 3 over 3. What do I do next? Multiply by the reciprocal of? So the denominator. Okay. So we're going to multiply square root of 3 over 2 times 3 over 4 square roots of 3. Can you tell me what happens?
Three square root of 3 over 8 square root of 3.
I don't disagree, but what can I do with the square root of 3's? So final answer? 3/8, and there you go. So that big expression simplified down to that, okay? So rule of thumb, don't leave fractions within fractions, and let's rationalize if necessary. What's up? We are adding it, so it doesn't matter. Square root of 3 over 2 plus 0 is just square root of 3 over 2. I did. 1/2 times 0, but I'm adding that answer. Make sense? Okay. But if it was times 0, yeah, I'd be done. My answer's 0. what was I going to say? Hey, guys, do you remember how to rationalize? I'm not saying it's going to happen. Excuse you. Hello. Hello. Okay. Do you remember how to rationalize an expression like this? 3 plus square root of 3? If you multiply by, okay, so let's explore just the square root of 3. If you multiply top and bottom by just the square root of 3, that still has a square root in it. Okay. Now let's explore 3 plus the square root of 3. 3 plus the square root of 3 times 3 plus the square root of 3. That's 9 plus 3 root 3 plus 3 root 3. That's plus 6 root 3. You didn't get rid of the root 3. No, you can't do that because you got to multiply top and bottom by the same thing. So, what, excuse you, is this, okay, thanks. What is this number? Called? C-O-N-J-U-G-A-T, conjugate. It's the conjugate. I want to make it all the way to the end. For a second there, I was like, wait a minute, I got to make sure I don't lose my spot. Okay. It's the conjugate. When you're trying to rationalize, remember when you had imaginary binomials in the denominator, you multiply by the conjugate. So let's see what happens. What's 3 times 3? What's 3 times negative root 3? Negative 3 root 3. But what's square root of 3 times 3? Positive 3 root 3. The root 3's cancel out. What's 3 root 3, what's root 3 times negative root 3? Negative 3. Which means my denominator is now just 6. Okay? So should you ever need to rationalize, you got to remember to make use of the conjugate. Okay? Now, that being said, I could simplify the 2 and the 6 and say 3, 1, and 3, right? Okay, anyway. All right, here we go. Draw a triangle like this. Draw a right triangle like this. Make the bottom angle theta and the top angle beta. So beta is just like make a long, elongated B. So just keep that going. Anyway. And let's label this as the y value, the x value as if it was in the coordinate plane, and the hypotenuse, okay? Doesn't really matter. I could have used A, B, and C, just so we can see. What is sine of theta? Y over what? Okay. Because that's what over what? And opposite of hypotenuse. Good. So y over h. Now, if you haven't already written down, write down cosine of beta. So theta and beta. So what is that? Okay, so cosine of beta. Cosine is adjacent over hypotenuse. So that would be y over h. Agreed? So sine of beta equals sine of theta equals cosine beta. True? What relationship do theta and beta have? What are they?
Equal?
Are they equal to each other?
Probably not.
No. We do know something that they, one specific relationship they have. Well, how many degrees are in a triangle?
90 equals 180.
Huh?
If you add those two, it's 90 equals 180.
Exactly. Theta and beta have to add up to 90 because the right angle takes up the other 90, right? So write this down. Theta plus beta equals 90 degrees, or theta plus beta equals pi over 2, right? Because 90 degrees is pi over 2. So solve for beta in this first expression. What does beta equal? 90 minus theta. Okay. So here's what I know. Sine of theta is equivalent to cosine of what?
Beta.
Beta, but what's beta? 90 minus theta. It's complementary angle, yeah? Okay. What if I asked you what is cosine of beta equal to? There you go, sine of 90 minus beta. As long as you know that like sine and cosine of the other angle in a triangle, right, other than the 90 degrees, they're the same thing, you can see that, and these are actually called cofunction, and so in a minute we're going to write these down on the back of our unit circle, okay? Do you think any other functions are cofunctions? Because sine and cosine are cofunctions. Well, give me one of the other trig functions. Okay, let's go with tangent. So everyone write down tangent of theta. Let me clone this page. Okay. Edit, clear. Okay, tan of theta. What is tangent of theta? X over y? So what do you think is going to be the cofunction to tangent? Okay, good. So cotangent of beta is equivalent to is it y over x or x over y? Okay, so remember, cotangent is not as like natural to think about because we think about tangent. We've thought about tangent for years. Tangent is opposite over adjacent. So if it's not opposite over adjacent, then it's adjacent over opposite, right? So adjacent over opposite. So x over y as well, right? So could we make I mean, are they cofunctions? Yeah. So that means tangent of theta equals cotangent of what? 90 minus theta? Bye. But that also means that cotangent of beta is equal to what?
And 90 minus beta.
90 minus beta. Okay. We have two other trig functions. Are they cofunctions with each other? What's the other two trig functions? Cosecant. So what is cosecant of theta? Why did you change to? Oh, okay. Cosecant is the opposite of what? Sine. So if sine is opposite over hypotenuse, then this is hypotenuse over opposite. So h over x, I agree. And then secant of theta, sorry, beta. Dadgummit. Secant of beta. Secant's a reciprocal of what? So if cosine of beta is adjacent over hypotenuse, then it's hypotenuse over adjacent? Okay. Okay. So here's what I need you to do. On the back of your unit circle, write down cofunction identities, or just cofunction. Write down cofunction. Now, how much you write down on this is up to you, but we'll go ahead and do, well, I'll show you what I mean. What's a cofunction to sine?
Cosine.
Okay, so we can write sine of theta equals cosine of 90 degrees minus theta. Now, what I've seen happen before is I write this one down, but then you don't, like students don't make use of the fact that cosine equals sine of 90 minus theta. You know what I mean? So I'm going to write the other one down. It's up to you on whether or not you want to write that down on yours. If you think you're good, then you don't have to. Okay. What's the next one that you want to write down? Okay, so tan theta is equal to cotangent of 90 minus theta. And that means cotangent of theta is equal to tangent of 90 minus theta. Now I'm using 90 degrees, but 90 degrees is equivalent to what? So if you wouldn't mind, like where you wrote cofunction, go ahead and write 90 degrees equals pi over 2. So that if you see a problem in radians, I mean, it's just replace the 90 degrees with a pi over 2, and there you go. Okay? So one more. Cosecant is equal to secant of 90 minus theta, or secant of theta is equal to cosecant of 90 minus theta. Okay? Okay. Got those written down? All right. Now, word of caution, if you write with big handwriting, try smaller, okay? And when you're writing on the back of the, so you will want to write these, oh, you already have that on the back. Okay. Do you have another unit circle that you filled out? Because I gave you 2. Did you fill out the other one? What you're going to want? Okay. I would use that one and write your identities on the back because we're going to write about, we're going to have over 20 identities. So you're going to want to, over the course of the next few.
For like halfway on?
No, we got quite a bit. Quite a bit. Not today. I'm just talking about in general, like over the course of trig. Okay, you're going to learn quite a few. All right, so find a cofunction with the same value as the given function. Write down sine of 84 degrees. Notes. Find a cofunction with the exact same value as the given function. So, what's sine's cofunction? Cosine. So sine of 84 equals cosine of what? 90 minus 84. And you can skip this step if you want to and just jump straight to the answer, but it is cosine of what? 6 degrees. And that's all I'm asking you to do. You'll see in a bit. Okay. All right. And part of it is just knowing for later, like things that have to do with the functions, knowing that they're cofunctions of each other. That really just means that, like, as far as the graphs go, it's just a flip and a shift horizontal. So you can see that they're the same functions with just a transformation. So write down cotangent of 4 pi over 3. Cotangent of 4 pi over 3. Now 4 pi over 3 is over 90 degrees, right? Let's see if this still works out. Cotangent, cofunction is what? So what do I put as the angle? Okay. 4 pi over 3? All right. Well, what is pi over 2 minus 4 pi over 3? How do we subtract these two? Okay, so we need to find a common denominator of 6. So multiply top and bottom by 3. Multiply top and bottom by 2. So I've got 3 pi minus 8 pi. What's that? Negative 5 pi over 6. Okay. Now, what I want us to do is look at our unit circle. 4/3 pi, what quadrant?
Third.
4/3 is down here at 240. Okay. That one is 0, -1. And so that means that must be -1/2, negative square root of 3 over 2. Yeah? I keep recreating, obviously, because I don't have the unit circle in front of me, but I just want to emphasize to you that that's the use of the unit circle. That's the use of the pattern. It's just to quickly be able to create it. What is cotangent? In general. Cotangent in general? Cosine over sine? Cosine is the x or the y? X. So x over y, what's that going to be? Okay, 1 over the square root of 3 or square root of 3 over 3. Cool? Okay. Where is negative 5 pi over 6? That's 7 pi over 6. 5 pi over 6 is right here, so this would be negative 5 pi over 6. And I know that, the relationship between these coordinate points is that they're just the opposite of each other. So, because that one was 1/2 and square root of 3 over 2, this one is square root of 3 over 2 and 1/2. Okay? We're trying to find what of that? Tangent. Tangent is whatever what? Sine over cosine, so that would be y over x, good. So negative 1 over negative root 3, which is just what? Square root of 3 over 3. Are they the same? They are. Just proving that this still works, even if it's past 90 degrees, okay? Okay, I couldn't really prove that one because I don't know what sine of 84 is, other than knowing that it's cosine of 6. Well, not necessarily, just like checking it out. Do the numbers work. Well, you are going to do trig identities, where I give you an equation, where I say this expression equals that expression, and your job is to figure out how. Using your multitude of trig identities. It's kind of fun if you like puzzles. If you don't, sorry. Finding an angle using a calculator. So I just need to quickly talk about this because, you learned this in geometry, right? If I give you a triangle or situation, whatever, Justin is up in a tree. I don't know why. How tall is the tree, Justin?
Let's make it
4 feet?
no,
40 feet?
a small tree. 60 feet.
60 feet.
Okay.
Okay, so do we know the distance from your cell phone is sitting on the ground staring at you? You're taking a video of yourself, evidently, okay? He's making a TikTok. What do we know? Do we know the distance from your eyesight to the phone or from the base of the tree? Eyesight? Okay, so what's that distance? 2,000 feet. We'll do 2,000 feet.
No, that must be a good camera.
He's not filming nothing. Guys, can you tell me what you think the angle will be? I'm just like ballpark.
Like in terms of like
Size. Like, what do you think?
sine of 60 over.
No. I mean like the angle. Like, what do you think that angle is going to be in degrees? Okay, that's what I want to hear. That it's pretty small, right? My picture is not to scale. Yes. So 2,000 feet away. Remember that 2,000 feet away, we're looking at something like this. And that's even an exaggeration, right? Because 2,000 versus 60 feet. So what I'm saying is, think about the reality of your situation and whether or not your angle makes sense if you find it. Okay. All right. So what's the relationship between theta 60 and 2,000? Sine. So sine of theta equals what? 60 over 2,000. It's really cool that you got it exactly at 2,000. All right. How do I solve for theta? Okay, you take the inverse operation of sine, and guys, that means you have to remember that you're applying the inverse to both sides. Okay, so don't put sine inverse after that. Doesn't make sense. And you end up with theta equals, and then what are you going to do? You're going to type in the calculator. Now, guys, what mode do you need to be in? Those are, I guess it's up to you. This situation probably makes best sense to be in degrees. Yeah? Because of the situation. But if they ask for the angle in radians, they need to be in radian mode. And all my calculators are in radian mode because of calculus. So you might need to change it to degree mode if you're using it. So sine inverse of 60 over 2,000 or 6 over 200 or 3 over 100. Yeah, what is it? 1.719. Yeah, that's a very small. That's why I was just making sure that we understood that that's a possibility, and that should be, right?
I'm almost confused how that works.
Well,
You see that tree?
you can't.
I don't think the Earth is that flat.
True. That's a good point to make. Whether or not, but if we just use, if there was, if they happen to be at the same altitude as the base of the tree and the cell phone. Okay. Good point. Good point. Earth is not flat. Um, or whatever. I actually watched this really cool video where they went across this massive lake and they had that helicopter and it's like it's kind of mind-boggling how water can have a curvature, but whatever. Interesting. All right, last one. Write it down. I'm gonna enjoy it. Oh, okay.
Oh wait, actually, this one's too bad. Well, we can keep here. This one's gonna be easy. We're gonna breathe.
So tangent of 32 degrees times cotangent of 58 degrees minus cosecant of 58 degrees times secant of 32 degrees. Does anything jump out at you? Okay, they're cofunctions. Tangent and cotangent are cofunctions. I agree. Secant and cosecant are cofunctions, and their two angles add up to 90, right?
Yeah.
So that means let's just write the first one. Let's leave it as tangent without a calculator. It does say without, right? Can I rewrite cotangent of 58 degrees in terms of tangent?
Yeah.
So cotangent of 58 degrees is equivalent to tangent of what? Of 90 minus 58, which is what? 32. Y'all cool? Cotangent of 58 is equivalent to tangent of 90 minus 58, which is its cofunction. Okay, so what's tangent of 32 degrees times tangent of 32 degrees? Tan squared of 32 degrees. Okay, so I've got tan squared of 32 degrees. I don't know what tangent of 32 degrees is, but there we go. We got that expression. Now talk to me about this other side. Do you want to stay with 58 degrees or 32 degrees again? 32, which means we need to replace what? Cosecant. Now cosecant's cofunction is what? So secant of 90 minus 58 is what? Secant of 32. So I've got secant of 32 degrees times, leave this one alone? And what do we get? Okay. Secant squared of 32 degrees. Now tell me what this equals. Without a calculator. Where have you seen trig function squared? The Pythagorean. What's is it tan squared plus what? Okay, so write down tangent squared out to the side. Tangent squared plus 1 equals secant squared. Okay. That x represents any angle, so it might as well be 32 degrees, right? Okay. What's tangent squared minus secant squared? Almost. If you subtract the secant squared over, and then subtract the 1 over, tangent squared minus secant squared of the same angle is negative 1. And there's your answer. Cool? All right. There you go. We're done. Glad you joined if you're on the meet. You can cry. That's fine. You guys can leave once you write down the homework or take a picture. Have a good weekend.